Welcome to our discussion of the quantum mechanical model of the atom. We've finally made it from Democritus to Niels Bohr and everybody in between. We've finally reached the point where we're going to discuss the modern idea of the structure of the atom and how its subatomic particles are arranged. So in this video, we'll be looking at the following objectives. We'll describe how electrons are arranged in the atom according to the quantum mechanical model, define principal energy levels, sublevels, and orbitals, differentiate between these different levels of organization, and define Heisenberg's uncertainty principle. So in 1926, a scientist by the name of Erwin Schrödinger comes up with equations that figure out where electrons are most likely to be. He hypothesizes that rather than electrons having these set planetary-like orbitals, that they're actually located in this electron cloud, this cloud of probability where electrons are most likely to be found. And he called these electron clouds orbitals. So our electrons are no longer located in orbits, but rather in these clouds of probability called orbitals. Schrödinger's work in 1926 with the electron cloud led to the formulation of Heisenberg's uncertainty principle in 1926, which was postulated by scientist Werner Heisenberg. So we detect electrons much the same way we see things, by seeing the light that bounces off of them. But because electrons are so small, when photons or packets of light hit an electron, the electron is going to get nudged off course. So now we know the position of the electron, but it's no longer going the same speed and direction that it was before the photon hit. So Heisenberg hypothesized that it is impossible to know exactly both the velocity and position of a particle at the same time. We can know one or the other, but as soon as we know one, then either the velocity or the position or both have changed because of the collision with the photon. So what does our quantum mechanical model actually look like? Well, there's a lot we're actually keeping from Bohr's model. So we're keeping our protons and neutrons in the center where most of the mass of our atom is concentrated. And we are still allowing our electrons to move up and down either towards or away from our nucleus based on the amount of energy they have. However, our electrons are now organized into principal energy levels. And there are 7 principal energy levels, and the shorthand being N equals either 1, 2, 3, or all the way up to 7 is our shorthand for principal energy levels. And they're going to represent a range of energy rather than a fixed amount of energy. So now this is where it gets a little bit tricky. Each of our principal energy levels is broken down further into sublevels. And our sublevels are described by the letters S, P, D, and F. And those sublevels are then broken up into orbitals. And remember, orbitals are a region in space where there's a high probability of finding an electron, an over 90% probability of finding an electron in those orbitals, in those electron clouds. And each of those orbitals can hold up to 2 electrons. The S sublevel is made up of only one type of orbital, and it has this nice round spherical shape. So this would be the S sublevel in our first principal energy level, and then this would be our S sublevel and orbital in our second principal energy level, and then this would be our S sublevel and orbital in our third principal energy level. Notice that our sublevels and orbitals, which are the same in this case, get progressively bigger as we move from our first principal energy level out to our third principal energy level. And remember that each of these orbitals can hold up to 2 electrons. So the S sublevel, because it only has one orbital, can hold up to 2 electrons. Our P sublevel is made up of 3 different orbitals, all of which look like dumbbells but have different orientations. So when we put them all together, all 3 of these orbitals put together in a P sublevel look like this. So this is what our P sublevel looks like. And remember that each of our orbitals can contain up to 2 electrons. So the px orbital, the x referring to its orientation on the xyz axis, would have 2 electrons in it. Our py orbital would have 2 electrons in it, and our pz orbital would also have 2 electrons in it. So our p sublevel can hold up to a maximum of 6 electrons, 2, 4, 6, 2 in each of its 3 orbitals. The d sublevel actually has 5 different orbitals, each with a different shape, and it's sort of this variation of a double dumbbell or a clover type shape, except for this 5th one, which is really unique to all of the other 4. But again, our d sublevel with its 5 orbitals, each of those orbitals can hold up to 2 electrons, so our d sublevel can hold 10 electrons max. Finally, our f sublevel is made up of 7 orbitals with a much more complicated shape for each. But again, it's the same trend that we've been seeing with our other 3 sublevels. Each orbital can have up to 2 electrons, so our f sublevel can hold up to 14 electrons, 2 electrons in each of its orbitals. So let's take a look at this chart that really sums up our quantum mechanical model and our electron configuration within the atom. So in this column we have our principal energy level. So our principal energy level 1 has 1 sublevel. And our 1 sublevel has 1 orbital. Our s sublevel has 1 orbital. And each orbital can hold up to 2 electrons. So our first principal energy level has 2 electrons. Our second principal energy level has 2 sublevels, an s and a p sublevel, and our p sublevel has 3 orbitals, and each of our orbitals can hold 2 electrons, so 2, 4, 6, plus the 2 from our s orbital and our s sublevel, and we get a total of 8 electrons in our second principal energy level. Our third principal energy level also has an s and a p sublevel, but it also has a d sublevel with 5 orbitals. And in those 5 orbitals, we can have 2 electrons in each of those orbitals. So our 10 plus our 8, and we get a total of 18 electrons. And finally, in our fourth principal energy level, we have 4 sublevels, an S, a P, a D, and an F. And our F sublevel has 7 orbitals. So we have our 14 plus our 18, and we get 32 electrons. Notice that each time I increase a principal energy level, I'm going to add a new sublevel, because as we move away from our nucleus and our energy increases, we're going to increase our number of sublevels as our principal energy level increases. And as you notice down here, there's a couple shortcuts to help you figure out how many orbitals you should have in your principal energy level, as well as how many electrons you should have in your principal energy level. So let's take a look at our principal energy level number 3. In our principal energy level number 3, we have 1 plus 3 plus 5. We have 9 orbitals, which is n squared, or 3 squared, because remember that n stands for our principal energy level. Same for 4. 4, I have 16 orbitals, and 4 squared is 16. To find our number of electrons, we simply use the number that we found over here and multiply it by 2. So going back to our third principal energy level, our 3 squared is 9, and 9 times 2 is 18. So using these will help you quickly determine how many orbitals and how many electrons you should have in your principal energy levels. So one way you can think about this quantum mechanical model of the atom is sort of like an apartment building. The building is the area where all the electrons are found. The floor, the first floor, second floor, third floor, all the way up to 7th floor is the principal energy level. The apartment is the sublevel, and then the bedrooms in the apartments are orbitals. And each of those orbitals, or each of those bedrooms, can sleep up to 2 people or hold 2 electrons. So for example, floor 2, or principal energy level 2, has 2 apartments, or 2 sublevels, an S and a P sublevel. And in those apartments, the first one, our S sublevel has one studio or one orbital, which can sleep 2 people. And then the other apartment is our 3-bedroom or our P orbital, which has 3 bedrooms and can sleep up to 6 people. Floor 3 or principal energy level 3 has 3 apartments, a 1 studio, an S sublevel, a 1 3-bedroom, a P sublevel, and a 1 5-bedroom, a D sublevel. And each of those bedrooms can hold up to 2 people. So floor 3 with its 3 apartments and its 9 bedrooms can sleep up to 18 people. So this is hopefully a little analogy that can help you sort of visualize the quantum mechanical model and the electron configuration. So that wraps up our discussion on the quantum mechanical model, our most modern model of the structure of the atom. I hope you took some notes, especially on the table that summarized our structure. Bring your notes and any questions you have with you to class.